Hey guys, we're live. Like last time, anybody has any questions in the Q&A, just type the question, name, and just so I know what's going on. Kevin, how's your week going, buddy?
It was good till the day, and then spiraled out of control like usual. But
Yeah.
yeah, just one of those. It's one of those never-ending months. So, about you?
I'm up in Oklahoma this week, doing some training. I actually got to work on actually connecting to Wismate to the XCM XCM 25D, basically the case control or the controller for the condensing units. And
Yep. Those things are great. Like they can do a ton of stuff, and they work out like really good. It's just I wish Wismate you could actually like see live stuff.
well, let's see. The thing was, like, apparently, so when I first got Wesmate, it was when it was like version 1.0. So I didn't have like the full capability. Like I couldn't see all, like we had downloaded from the controller, and I basically couldn't see, everything that was on there. So I had to update it. And that was like, I got it when they first were doing, not CoreLink, Visiograph. Oh my God, I'm drawing a blank here. Help me out. Not Visiograph. Visiograph is the actual screen. CoreLink. No.
Oh, those junky controllers they put in all the Walmarts that like just disappeared overnight.
And they're still out there.
Yeah, the 90% of them are gone. Those things were a disaster.
They're still the man.
It was like the E1 of case controllers.
So my understanding, I just talked to a guy from Emerson. They're doing the CC 200, and I asked him. I said, is it more like a True Blue Emerson product, or is it a Dixell? He's like, Dixell.
Yeah, I mean, I wish they would just make their own product and stop trying to integrate Dixell into everything. I mean, it never matches right.
Well, that's the only thing. The problems that you said were basically, you have basically where on the E2, like all the options don't match up for any of the stuff that's actually per on the Visiograph. Like there's way more options, and who has a question? What do you have a question for? Raise your hand, ass. And Jordan, go F yourself. Jordan likes orgies with cats. So just letting everyone know. I don't know who's saying what's up, guys. Unfortunately, I can't see on the live stream. I don't know why. I don't know if on what website it's coming through on. But no, I'm training up in Oklahoma this week. Got to work on that particular controller. And if anyone has any bullseye stores with the XM 678s that keep icing up, just let me know if you have icing issues in the drain pan. I got a fix for you.
Allegedly.
No, it works. The past two stores that I changed the programming on, it worked.
Allegedly.
Shut up. What's up, James?
Says the guy there at 2:00 in the morning de-icing the case.
All right. Well, he's gonna call me when he's pissed. Come to Atlanta for training. I was just in Atlanta not too long ago. How does an air rifle? What's training? Why? Why do you say that?
Oh, no comment.
Tim Provencio. How does airflow rifle through a case? You know what? They're picking every single little idiosyncrasism that I have when I talk, and just making fun of me, so go fuck yourself. Greg, you can talk to me when you get your big boy pants and you can figure out a schematic. All right, how about that? What's your fix for the XM678 problem? So if you look at the schematic on the 678s for the Hill Phoenix JXR cases, I think that's the model number. The drain pan heater is basically hooked up to the output or the relay that turns the fan off and on. So when it's turned on, it turns the fan on. When it turns off, then basically it kills the. When the fan output is off, it turns on the drain pan heater and vice versa. So what was happening was because Hill Phoenix, I guess does the programming for these, or so I don't know who basically does the programming, but what was happening was it wasn't as soon as the defrost would end. As soon as it would hit termination, it would kick on the fan output. The fan wouldn't kick on because there was a mechanical control. It clicks on the outlet. But basically the whole time where it should be heating up the drain pan, it wasn't. So basically all the ice was forming up in the drain pan, just causing an ice dam. And they basically, I changed it from no probe control for the fan to like probe 6 and made it obviously act like a walk-in hot gas system where basically you have the Ranco controller on the back. Stop reprogramming stores, Brett. I don't know who that is. Like I said, guys, type in your name just so I can see who's talking. What's that, Kevin?
You're saying to apprentices.
Leaving comments. Dre here. These are all cats that I've worked with. No one's going to ask a question. Greg usually will call me at like 10 o'clock at night asking me a freaking question because he's reading something stupid. I'm not an apprentice. You are if you can't figure out that schematic, Greggy. ORC. I'm surprised Nathan's not on here asking you to take off your clothes. Where the fuck is our ORC? Jesus. Go ahead. What's good oil pressure, Kevin?
There is no good oil pressure on a screw. It's going to be whatever your discharge pressure is. There is no true oil pressure. It doesn't have an oil pump. It's being injected into the screw itself from discharge pressure. So you're constantly circulating oil from the discharge of the oil separator through the solenoid and injecting it into the lobes of the screw to, depending on what the compressor is. It's going to inject by the bearings in the lobes of the screw to lubricate it so it has no true oil pressure. So, it's going to, you're going to have a little bit of a differential depending on where the switch is. I think on the Bitzers, it's suction to discharge, Brett. Is that what it is?
For what? I'm sorry.
The Bitzers just use oil flow. They use an oil flow switch. I think the Carlisles use like a pen, but I think it's only like a 5-pound differential.
I've never worked on the Carlisles. Always Bitzer. But yeah, usually
Carlisles have like a 5-pound.
Yeah,
it's like a 5-pound differential like switch. But Bitzer always uses a flow switch. That's 1,000 times better. Why
is oil temperature critical for screw operation? Because obviously, the hotter the oil gets, the hotter the discharge temperature is going to get. What's the safety open up on usually, Kevin, on those?
It depends. I think some of the screws are like 250, 230 degrees. I've seen them at 210. It depends on the application, but the hotter the oil temp gets, the hotter your screws are going to get, and the hotter the rotors are going to get, and then your discharge superheats is going to skyrocket. So the cooler you keep that oil, but there's a line where you can't cross with the oil temp, because if it gets too cold, then it gets too thick, then it starts causing you start getting oil flow issues.
Yeah, if anyone's ever had to pump in oil by hand, screw oil, I forget what was it Solstice 170 or something like that. It's thicker than syrup. It's ridiculous.
Yeah, we had a store. We had a store in Chicago that I used to take care of. It was kind of like my place. Well, it was a big manufacturing or a food production place. They had no holdbacks on any of the condensers. Some retarded company in Chicago changed the tower out, put condensers on the roof, didn't put any holdbacks in. And these were like massive racks. Each rack had 4 screw, like 150-ton screw compressors, massive. So they didn't put any holdback valves in. So R22 middle winter, they're V-style Guttner condensers, and the air blows through them, and you'd be lucky to get the head pressure above 70, 80 pounds. So, I mean, it would be constant oil flow issues because the oil was too cold to get a differential. You need a certain head pressure on a screw to get that differential too. I mean, it just depends on the operating envelope of that compressor. But I mean, eventually, until you get that pressure up enough and that temperature up enough, that 170 weight oil is not gonna move.
So apparently, one of your buddies is on here. I hated that account, Kevin.
I think everybody hated that.
So one of the things about some of the Sam's Club and the Walmarts, if they do have the screw racks, you'll see this system called a jet cool. Basically, what it does is the liquid coming back from the condenser drop leg, coming back before it hits the receiver, it goes through what's called a thermal siphon. Basically, it's a receiver to ensure that you have a full liquid at the bottom, and then basically they use that through usually a Parker solenoid that they pulse and try to maintain a certain temperature. Well, what they do is after the liquid goes through there, you're going to have some vapor left, right? Because you're going to have that latent heat change. And then that vapor actually goes back up and gets reconnected to the discharge line and goes back in the discharge line to get recondensed.
Yeah, I mean, most of the screws I've seen, besides the Carlisles, I mean, some of the Carlisles are too. They're all vapor injected screws. I mean, vapor injected screws, you get a lot more efficiency out of because now you don't have as high a compression ratio all the way through the screw, and then at the same time, you're also cooling the screw down and getting free subcooling in the end.
Dre, with oil pressure, the loss of oil pressure you're looking for, some screws have auxiliary pumps. So Andre works on industrial, Frick, Velter, Sabro. So that's what he's talking about. And single stage, they'll cut out at 185. Yeah, but you got to remember, Dre, like those are meant to have way lower head pressure. You know what I mean? Someone's asking us, can we do an episode on hydronic and chillers? Hydronic, dude, I don't know much about hydronic. Kev?
I mean, pumps and stuff. Like, I mean, we get into pumps. I mean, I don't really get into boilers much. I mean, yeah, I learned a lot about pumps last week, or no, 2 weeks ago with that oversized pump on that startup. I mean, but yeah, I mean, chillers, we do a little bit of chiller work here and there, but I mean, that's more of like another specialty thing. I mean, that's, racks are one specialty, and, chillers and boilers are a whole nother, specialty. We can go over a little bit of basic hydronic stuff.
Yeah. What should the superheat bring set to the expansion valve for a desuperheating valve? Greg, it's you're basically just setting that to make sure that you're maintaining a good temperature, not that you're too high on your suction. What he's referring to is when you have a hot gas valve on the suction, basically because you're injecting hot gas into there, you're going to end up juicing that line potentially up to 100 degrees or whatever. So we want to compensate that by putting liquid in there. As long as your superheat's not crazy coming back to the compressor and it's over 20 degrees of what it should be, and you're not above the threshold for the compressor. Do you guys regularly use meggers or insulation testers on motors? Kev, go ahead.
I mean, yes and no. I mean, it's kind of a hard thing. So like meggers get overused. Meggers are a predictive tool. I mean, they should be used to predict a motor failure over time, is how a megger should be used in a true sense. Like you should be, megging a motor, and then writing it down what the meg ohms are, and graphing it over a predicted period. It's supposed to help you predict when a motor winding is going to fail. With that being said, yes, you could use it to find shorts or poor insulation quality. I mean, yeah, I mean, there's been times we use it, for that. I mean, but generally, if you got something, say a compressor's, tripping a breaker, generally it's probably going to ohm out bad and meg out bad. So, I mean, my megger is probably the least used tool in my truck. I mean, I'll use it on occasions, but it's not a tool I go to grab a lot, and it's not something that most techs I would expect them to spend a lot on. Amazon has like a kick-ass megger for like $87, and I forget, I'll have to find a link for it later, but it does as good as my Fluke 1587, which was like a $900 megger. I mean, this $87 megger reads the same exact values. I tested it with a bunch of guys that I had them pick it out, and I mean, it reads the same exact values. I mean, there's no sense in spending that money on a megger unless you're doing a lot of like bigger motor work and stuff like that, and VFD work. If you're doing a lot of VFD work, yeah, megger is important. If you're just doing general service, I wouldn't spend $900 on a megger.
And you can use that to compare stuff too, right? So like I've had a rooftop unit where basically the blower motor kept making the VFD fault out on ground fault, and then I took another motor that was basically another rooftop unit that was identical on the same roof, meg that motor. The motor that wasn't making the ground fault was about 5 meg, and the one that was ground faulting was about 2.5. So basically we ended up just ordering a new motor because the megs were low enough that it was causing the ground fault on there. I think some of the Walmart distribution use yeah, they do. They usually use carrier chillers. They do have circuit setters on the outlet of the units. They commonly they do what's called floating approach. If anyone's listening to the glycol podcast, we talked about typically they tries to maintain like an 8 to 12 degree approach as far as the saturated suction versus the leaving water temperature. And then as it starts maintaining temperature, it'll actually start, going up higher and floating the approach temperature up. And then at that point, because you're cutting off the expansion valve more, then you'll have to start cycling your compressor. Why does Kevin look like he's using a potato as a... What was that?
Potato as a webcam. They have shitty internet. I've never actually seen a Walmart distribution center.
No.
I mean, they're using glycol for the medium temp.
Yeah, they have like they either have the hill. It's just a regular. He says distribution center. I'm thinking that he's just talking about some of the bigger Walmarts. I could be wrong, but some of the bigger Walmarts, they, instead of having the regular Hill Phoenix set up, they have the carrier chillers up atop.
That seems incredibly inefficient when you should have ammonia.
Why does two-stage racks use TX valves with LT power heads to desuperheat low-stage discharge? Because you're basically pumping discharge gas into the ass end of the compressor off of the primary stages. So to help cool that process, you basically have, those liquid injection valves basically, throwing liquid in there. That's what the L2 power heads are, right? They're the liquid injection ones.
I'm going to be honest with you. I've never looked at an L2 power head.
No, okay. You'll get the link after. Relax. Carl. Is vacuum pump oil supposed to be changed, or is it like oil in the work fan? Just when it gets low. You're an ass. No, he's not being serious, but change your oil every single time. It'll help with the longevity of your pump. If you have moisture in
Don't
the
act like
compressor,
you change your oil every.
yeah, I do.
You don't even have a vacuum.
You're right. Soccer mom vehicle does not have a vacuum pump in it. I drive around in a Chevy Equinox. If you have moisture in the compressor oil, can you read megohms to ground? Sometimes weak insulation on the windings can be detective for predictive failure. Absolutely.
So, but here's the thing: like, there's a lot of things. Okay, yes, they can be predicted for detected for predictive failure on normal motors. If you're megging normal motors, a compressor is a different scenario here because there's a lot of different factors with a compressor that can give you false megohm readings: acid in the oil, moisture in the oil, bad oil, liquid refrigerant in the oil or in the crankcase could give you bad megohm ratings. So there's a lot of things you gotta take into account with megging a compressor. I mean, there could be things in the environment that are causing bad megohms. So this is one thing to look at. Like if you're trying to do predictive overtime on a compressor, you need to take that into account. If you have acid in the oil, you're going to have bad megohm readings. And also, don't ever make a scroll in a vacuum.
What'll happen, Kev?
Oh, it'll blow the fuse light right out of it.
I've seen a few times where a compressor is ohmed out on a meter and not grounded, but the dang thing still trips the breaker. Recently had two I misdiagnosed as bad compressors. Ended up another contractor changed a welded contactor, and both are running.
Yeah, it's a real kick in the dick there.
Come on, we've all had it. We've all had that happen once or twice. Skip, put the link on there so they stop complaining about it. Wire some evaporator. Got variable speed fans. Why not just a flat suction? I'm assuming they're probably trying to goose the UL rating, saying that when it's not actually refrigerating, they're going to slow it down to a second speed. Have you seen those, Kevin? Usually on like the Trenton units.
Oh, every new evaporator from Heatcraft has this shit in it, and it sucks ass. Like it's all I've been dealing with for the last 2 weeks are these 2-speed fan motors, and it is nothing but a nightmare because half the time it's not in any of the RC drawings or any of the EC drawings. There's no way to control it. Nobody's thought this through, so we end up going in there and jumping this shit out. And here's the other downside to this. So it's all with this AFE rating, hippie bull crap. That's I mean, it does work, but the problem is when nobody thinks about how they're going to control it, it turns into this disaster. So it's pointless at this point.
Yeah, because unless
you're taking a motor.
Go ahead. I'm sorry.
Go ahead. I mean, you're taking a motor that costs $60 and making it like $300.
Well, unless you have because usually they're switched via thermostat connection, right? So unless how many times is the is the control anywhere near it? You know what I mean? All the valves and stuff are typically by the rack. So how do you switch it from low speed to high speed?
Yeah, I mean the Bullseye store, they're running 24-volt wires into the coils, and they're using a 24-volt relay. That's if the OEM actually puts a 24-volt relay in there, and you have a bunch of 110-volt relays or 208-volt relays. But I mean, that's so. I mean, there's got to be some thought process in there. I mean, yeah, it does work, but I mean, here's the other thing: you're not getting with off time stuff. So if it does cycle off, there's been issues where they're cycling the fan speed during defrost. Okay, well now the fans are going slow during defrost. Now you're getting a really shitty defrost on off time defrost. So this whole thing has to be thought through, and you have to be able to force them into high speed during defrost. They will not defrost properly.
So moral of the story is make sure there's good planning on it so it's actually utilized well. Because Kevin's right, you can't just run those things at a lower speed while you're doing the defrost because the normal 40-minute time that it might be might now take an hour 20 because you're basically moving, maybe half the amount of air across. Can you give a big?
And then
Go ahead.
And then the other caveat to this is, actually being able to get the motors. I just waited 4 weeks for an evaporator fan motor.
Yeah, but that's everything right now. Any manufacturer you talk to right now.
But if I were to take that motor, that exact coil 2 years ago, I would have had that motor in my truck. I could have gone to any supply house, picked up a Fastco motor, and threw it in. Or even like a ECM motor. I could have thrown an ECM motor in there off the shelf, stud mounted ECM motor. But now I got to buy a $300 motor and wait, 4 weeks, 5 weeks to get a motor. It's ridiculous.
You know how many motors you could probably fit in your truck if you actually took out some of those fucking pack outs out?
There's a lot of motors in that truck, believe it or not. There's more parts in there that most people have.
No, I agree.
That's why I keep blowing tires.
What's up, Mick Perrin? Carl. POE oil systems. I always use RCW 48s instead of 4864s. Help with moisture. What are your guys' thoughts? I mean, if you guys aren't introducing the moisture, then you wouldn't have to use the RCWs, right?
I mean, RCWs are a slightly better core for that, but I mean, generally, I'm always doing startups. So I mean, I get what the OEM sends out, which is the lowest quality possible.
By the way, I wanted to tell you, I saw a transcritical rack the other day and only had dryers on the medium temp suction, not the low temp.
Yep, that's all advancer racks do that. They only filter the medium temp suction coming back. They don't do anything with the low temp. They don't do anything with the liquid line. They use a strainer that 90% of the time we have to pull a screen on because it's useless. And that's what they're using.
All right.
And they're process. They're going to catch most of it coming back from the suction. They're going to get most of the filtering done. So I found that megger. So it's a BS. It's BS side VC60B plus. Said like an Amazon. It's $47. You literally can't beat it for $47.
Skip said he found one too. Leave that up for a second. Damn all that hippie bull crap. Got to be a Title 24 complete. 6 weeks for mobile Polyrex grease for the ball door motors. Yeah, man, everything's on freaking back order right now. Everything.
But yet every customer expects it done like the same amount of time that it was like 2 years ago. They want it done in like 2 minutes.
I have to bring this up. So like, because I saw it on on the supermarket page. And, all the conspiracy nuts were going crazy over the Walmart that was all, closed off and stuff. And like people were throwing out the weirdest thing. They're doing it on purpose. I'm like, no one realizes like how much, the back orders are for everything out there. With the long lead times in mind, what are the pros and cons of compressor rebuilds instead of ordering compressors? If you can get the parts. What?
Like getting a rebuild compressor, like a American or whatever that company.
No, he's talking. I think he's talking about rebuilding it out on the field.
I mean, I guess you could if the cylinder walls are good. I mean, it's just it's completely plausible, but it's just not cost efficient.
No, because you'd have to spin the motor almost upside down because like most bigger compressors, they have access holes in the side, like the bigger Yorks. It looks like they're 2, 4, 6, 8, 10. It looks like they're 10 cylinders, but in reality, they have access holes for you to actually, work on the connecting rods and everything like that. But like on the Copelands and the Carlisles and the Bitzers, you'd have to spin the thing 180 degrees in order to work on it. Go ahead, Kev. Sorry.
Yeah, I mean, and then you're talking. I mean, some guys may be able to do it. Most guys probably couldn't do it. You're gonna have guys out there that are not using torque wrenches and everything else, and not torquing a bolt on one on a dryer shell's one thing. Not torquing a bolt on a connecting rod is another. That's you're just asking for more problems, and I mean, but by the time you do labor and your liability, and you're better off just getting a compressor from a supply house and not a rebuild from some remanufacturing company that just slaps some new paint on there and sends them off.
There are some local shops. We have one local in Dallas called Compressors Unlimited, and super, super nice guy. Has been in the industry forever. And, he doesn't do like a cheap rebuild. And like he basically has every single part. So if ever we need Carlisle valve plates and stuff, that's where we usually get them from.
There's a difference between a rebuilder and a refurbisher.
No, right? Agreed.
There is companies out there that just slap valve plates on them and make sure the pistons go up and down, and they will literally repaint them and send them out if that happens.
Yeah. You want is that just cost savings or what? What's the thought process with the medium temp suction dryer?
It's just their design. It's not, there's no cost savings. It's just their design. That's how Advancer designs it. They figure there's so much velocity coming back through the medium temp suction, and so much of that's where they're going to catch the majority of their stuff. And they use a strainer on the low temp, or on the liquid going out. There's a Y strainer with a really thin, really fine screen in there, so they're going to catch everything from that. I mean, most CO2 racks, you have less contaminants in there. I mean, especially if you're purging, until the compressors start blowing apart.
Roman, how can I make a compressor smaller in a given system without losing much efficiency? Raise the head pressure. You raise the head pressure, you'll basically downsize that compressor by a little bit. If you guys take the Copeland mobile app, put in any compressor, not any of the vapor injection stuff, but like the regular scrolls, regular recips, and you play with the pressures as far as, like, let's say you're maintaining 20 pounds on the suction and 75 for your saturated condensing temperature, and then you increase that 75 all the way up to 120, you'll see the capacity drop probably almost 30%, right, Kev?
It depends on the compressor, but yeah, I mean, it can. But I mean, in that sense, you're also just tanking any energy efficiency you had.
Yeah, but see, unfortunately, like in Texas, where like they size everything to be in the devil's anus, like how hot it gets, they basically sometimes the compressors are oversized in the wintertime. So then it just brings the suction pressure, stupid low, because basically now it's gaining capacity. Or Roman, you could also do to basically compensate for like an oversized compressor. You could do hot gas bypass and de-superheating.
DC. What's that?
I have no idea what the hell it was. I've rebuilt engines, and compressor should be cake, no break in the rings, or Cam to worry about. He's got a point. Compressors. Have you had much luck with
No, I cannot stand that. Like in my last shop, the sleazy service manager would buy like a ton of those and slap them off as brand new. And I have had more of those things lock up on startup. I drug a 6-cylinder Carlisle up a flight of stairs with two of my buddies, up an entire flight of stairs, put this thing in. It ran for exactly 30 seconds and locked up. Like those things, they just slap valve plates on it and paint and just send it out the door.
How do you know you guys didn't drop it down half the stairs? Because I know you weren't pulling it up. There's no way.
Oh, we winched it up. Are you kidding me? I built an intricate like winch rig, and it came right up the stairs, coming back down, and we were yanking it down the stairs with the Big Joe.
Hold on. Walmart's only shut down for a day. And it was the employees could clean drip pans and easy access for the floor. They were also stocking and organizing. Oh, I think you might be talking about the Walmart that was all plasticated off, that everyone was having conspiracy theories about. That's what I'm talking about. Just sent two compressors unlimited. I said that to trigger. And someone else never had any luck with A1 compressors. I don't know. We didn't, in any of the shops that I've ever like worked at, I don't think we've ever gotten any of the A1 compressors. You know what I mean? When I worked for DeVault, we actually had like a compressor rebuild shop, like at the shop. Either that or like they rebuild them on site, because most of the facilities that they had their own, basically, winch system and everything, like, at the actual facilities.
Yeah, it's like a 75 to 85% failure rate. I remember the last A1 compressor I put in before I drug up. The threads in all of the MPT fittings for like the high pressure controls, they just shot that bitch in with an impact. Like it was like every single fitting was on an angle.
They're all stripped.
And they just sent it. Oh, they went straight in with a Dugga machine. Like there was no threads left in the casting.
What's the actual conversion for the Dugga versus the torque? Is it one Dugga per five cubic feet?
If you're using the big Milwaukee, it's two Duggas, and 3 you're going to snap it.
Title 24 compliant. Just going through to make sure I didn't miss any questions. I've had great luck with compressors unlimited out of Seaganville. Where the hell is Seaganville?
Some podunk town, probably up in Pennsylvania.
I don't think there's a Seaganville in Pennsylvania.
I would rather just get a Copeland compressor that's been rebuilt by Copeland. The last A1 compressor we did came with a paper stating it was like mocking the last tech that changed the compressor. Like it came with a paper stating on how the compressor that we got that was rebuilt supposedly was fine if they just put a valve plate on it and something else. They're literally mocking the person. Then I put it in and it ran for 30 seconds and locked up.
Oh, so just so I can feel like an ass, Seaganville is actually just south of Dallas. Sorry. I just always called Dallas. Oh, I'm missing Nathan right now. I thought he'd be on tonight. Oh, I'm not going to look at that. And if you guys don't have any more questions, we're going to bounce.
Something.
Go ahead. What's up?
Hold on here. I got something. Have you seen the new Heatcraft evaporators, like the with the blue plastic pans, the medium temp ones? Have you seen them icing up? I have seen nonstop medium temp drain issues with these things icing up. This is like the 5th store I went to today. I de-iced 4 different drain pans in stores that like have been started up in the last like 3 months. I mean, the drain pitch is all right. Like the drains drain fine, but the pans ice up in every single coil.
Do you think it has
They're all
to do with
holding water?
The fans?
So maybe the fans, or like, because I did a test today. Like I mean, I threw a level up on the walk-in. I mean, my guys put this up. Everything's level. Everything's plumb. Like the drains are done right. I even had them on this one. I had them drop the drains down, like out of the coil, come out 2 inches down farther than what the spec shows, and then hit the wall. I mean,
Yeah.
it's trapped properly. They do not drain right. Like I literally had to take the drain pan and I had to hang my fat ass off the drain fitting and like bow the pan in order to get the water to like flow to the center of the pan. Like it's any water on the TXV side and the other side just sit in the pan. And I'm talking like half an inch of water. And then like the whole coil, it's like they didn't break the pans right. Like they didn't put a cross break in there to get them to like flow. I seen one on Facebook last night. I seen somebody else complain about pans iced up. Like this is, I mean, it's been. I run full speed all the time. Like they're locked in full speed all the time because there's nothing. This particular customer didn't even know they had those, so there was nothing to control them. So, and they just use CDS valves, so there's nothing to control them. But I mean, they're just not draining properly. And I've seen it on multiple.
You say they were plastic?
So the pans aren't plastic, but the ends of the coils, they get those blue plastic covers.
Okay.
So it's the new style Heatcraft coils. It's their new the ones that came out in the last year.
Okay. So instead of having the metal on the sides, it's the okay. All right, I've seen one set.
It's the AFE that bullshit compliant evaporators is where it's happening at. But it's real weird. It's like it's just the water sits on the edge of the drain pan, maybe like 8 inches in on each side, and it will not drain at all.
You know what? Would I be?
I mean, it started getting better. Pull down the pan, but I mean that's kind of horse shit.
Yeah, what I'd be curious to is if you basically took like a smoke pen or something, something to kind of like test the airflow to see if it's doing some kind of venturi where it's actually just hanging out in the sides. You know what I mean?
I mean, it very well could be. I mean, but I don't see what it'd be different than. I mean, the motor's the only thing different. I mean, the whole design of the coil, I mean, I think is like they went backwards. I mean, the motor's just like sit in grooves. The whole bracket when you out, like it's just a weird design. Like I mean, they're moving a shit ton of air when they're in high speed.
Yeah.
I honestly don't think. Yeah, I honestly don't think the pans are deep enough. That's another thing. Like so, like I was de-icing this thing. I mean, I cleared the drain. I mean, I've de-iced hundreds of coils. I mean, I'm barely going with the water, and it's just blowing right over the drain. There's only like maybe a quarter inch of a lip on the back of the coil. Like, I don't think the drain pan is deep enough because I mean the old drain pans were like a half an inch to 3/4 of an inch deep. Like I don't think the new ones.
What a dick.
What about when his eyes start rolling backwards?
Shut up! You're a dick too. You know what? I'm leaving. I'm leaving
super mode.
I'm leaving your fucking rant in from last week when we recorded. Not sure if y'all do a lot of retrofits or install, but what's the quality been like of the new refrigeration equipment? HVAC equipment has been quality shit. A lot of new equipment with leaks. Kevin, I want you to answer this one.
There is no quality control. Everything is just a big old pile of shit. And then, I mean everything. Like the last 6 stores I started up, all the racks have shown up with solenoids in backwards, parts missing, stuff mispiped, pieces missing.
But
the wirings is another
quality. It's quality control because everyone's in a rush to get it out.
Or like the Hussman case yesterday that came in that we were piping in, and I look at it and it says flat on it. I'm like, oh, that's nice. They knew it was flat. Just let it leave the factory. So they missed the whole joint on a coil. Like, I mean, that's the kind of stuff we get to deal with in the field. I mean, there is no quality control. Like electrically, I mean, good luck.
Hot glycol defrost. You've dealt with this, no?
Not a fan. I think warm fluid defrost causes more problems than it's worth. I mean, there's certain circuits, certain things that I mean, warm fluid's nice for, like meat cooler coils, like stuff like that. I mean, to be honest, I mean, warm fluid, all it does is it increases the kW usage on the system because I mean, you're just heating up fluid and you're putting it back into the return side of the pump, so you're just increasing the glycol load. And I mean, certain customers like to do that, I deal with a lot, do every single case. And yeah, their defrost times are a lot quicker. And I mean, they do get the whole coil thawed out. But to be honest, the warm fluid causes more problems than it's worth. So, I mean, I'm not a big fan. And I'd rather just be off time and electric defrost for whatever it is. I mean, for what it costs for warm fluid defrost, you're going to save that in KW usage using electric heaters. I mean, warm fluid defrost, I mean, depending on the setup, I mean, it could be disastrous if it's not set up properly.
Warm fluid. Yeah. What's the well, how do they actually do that? How do they actually warm up the glycol to shove back in the pipe?
So the way that Zero Zone does it,
Mm-hmm.
they take supply pressure from the pump outlet. So they take that and they tee it off before it goes to the heat exchangers, and they pump it into a heat exchanger on one of the racks, and they run discharge gas through it. And what they're trying to do is they're using a three-way valve on the outlet of the coil. And what they're trying to do is they're trying to maintain a 50-degree glycol temp going out to the loop. So for the warm fluid loop, so they modulate the three-way valve to keep it the loop temp at like 50 degrees, and then what they do, so that line is at pump supply pressure. Now, when it gets to the valve stations, when it goes into defrost, they shut the supply solenoid on the glycol line, the cooled fluid solenoid. They open the warm fluid solenoid, so it goes in the same way as it normally would. It goes through the bottom of the coil all the way up the top. Then it comes back into the return, just dumps right back into the common return. So obviously now you're sending 50-degree warm fluid through there. You're going to lose some heat. You're going to get down to 40s. So now you're sending 40-degree glycol back, maybe a little colder. You're sending that back to the loop. Well, that entire thing, you're just increasing your rack load tremendously, because now you depending on the circuit, you could have quite a bit of warm fluid flowing through there.
Honestly, I've never seen a three-pipe glycol system. But no, I mean, it makes sense. And I guess the same way with, having the circuits that are not set up properly will cause icing. I guess the same way with, defrost, right? Because you still need to maintain that certain GPM through there.
So the last 3 stores I've done, no circuit setters in the entire store. All auto setters.
Are those the Danfoss ones?
Spring-loaded auto. Oh, these are spring-loaded auto flow setters. So they have a certain their size for a certain GPM and a certain delta P, and that's how they know how to regulate flow based on that. So the auto flows are like becoming more and more popular, like on stuff like this last Costco I did. Every single coil had auto flows on it, no adjustments at all, which kind of screwed you in a sense. And some of the and it's kind of hard to like get them dialed in. But I mean, the flow, there's no guessing with the flow rates. There's no guys, messing with valves. There's none of that. It's just the flow is what the flow is.
Well, because I saw an ad for Danfoss today where basically they had a circuit setter that basically just you turned it and it maintained a certain GPM. So I didn't know if it was something comparable to that.
Sporlan actually makes a CDS style driven valve to replace the circuit setter.
All right. There's nothing really else in the stream.
All right.
You got?
Oh, you ready to call it?
Yeah, we're gonna go. All right, guys. Listen, have a good night. We'll see you next time.